Okay, good evening all of you and welcome on GW. So please, first of all, audio and video is clear. Please confirm the audio and video in comment box. Is I'm audible? Okay, thank you, thank you, thank you. Okay, is I'm audible? Okay, sure. So let me move on the session. So in this session, we are going to discuss. Okay, thank you, thank you, thank you, thank you. Okay, so let me start the session. And in this session, we are going to discuss one of the best fluid mechanics question that will, based on your gate examination, or you can say a pattern of the gate. And in this session, we should cover all three type of question. First, we can say MCQ type of question, NAT, and MSQ type of question. Okay, so let me start the session. Let me start the session. See, this is a complete schedule which we are going to follow, and I hope you know the schedule. Maximum subject is covered. Basic thermodynamic, engineering mechanics, mathematics, material science, and manufacturing process 1. Applied thermodynamics, where machine design, aptitude, industrial theory of machine and vibrations, manufacturing process 2. And today we are going to cover the fluid mechanics and hydraulic machine. And if you miss the session, previous session, you can just go to the playlist and cover these all session. Okay, and tomorrow is the strength of material by approved sir. Same time, 4 p.m. 6. Tomorrow is strength of material by approved sir, and the last one is heat transfer by Sandeep sir. Okay, so let me move on next. So this is my complete team Drona. You all of you know about the team Drona. Actually, okay. So let me on first question. See, the first question is from laminar flow. I think some issue in live session. I think the streaming is not in proper way. Please just comment me. Just comment in the comment box. Is all the thing is fine? Please confirm in comment box. Please comment in confirm in comment box. So all the thing is okay. Okay, so let me move on our first question, and the first question is from laminar flow through the pipe. Okay, so get ready for first question. And first question is MCQ type of question. First question is MCQ type of a question. And this question may be, you can say, belong for 1 mark. This question is for 1 mark. And the nature of question is MCQ type of question. So let me just read the question first. Here, please read the question carefully, because if you make a mistake during the reading of a question, then 110% you cannot get the correct answer. So let me first read the question. The question, they are saying that the flow of a fluid is laminar. Okay. The question, they are saying that the flow is laminar in nature. Then which option is going to be correct for laminar flow? We all know that for a pipe flow, or you can say internal flow, clear? Internal flow, or a pipe flow, or you can say internal flow. We know the range of laminar. We know the range of Reynolds number, clear, for laminar as well as a turbulent. Let me, this is a pipe, the diameter is small d, and the diameter is also called the characteristic dimension in pipe flow. Clear? Okay, good. Anjali, yeah, the answer is B. Sure. Clear. So let me just start the solution. If this is a pipe having a diameter of D, and that diameter will also call the characteristic dimension of the system. Clear. And if a real fluid is flowing inside the pipe, if a real fluid is flowing inside the pipe, real of fluid. Clear. And the parameter for this fluid should be density is a rho, dynamic viscosity is a mu, and the mean velocity of flow is u mean. That is the mean velocity of flow. This should be a mean velocity of flow. Clear? So if these are the parameter, we can relate these parameter by using a non-dimensional number, a Reynolds number, and that Reynolds number is based on the diameter. Clear? So what is the Reynolds number? Reynolds number should be the rho. Characteristic dimension is the D, diameter, and mean velocity of the flow is u mean, and the dynamic viscosity is the mu. Clear? And if this Reynolds number based on a diameter less than 2000, or you may also say that, sir, this is less than 2300. Clear? Then flow should be a laminar. Then flow should be laminar. Then flow should be laminar in nature. Then flow should be laminar in nature. Clear? Flow should be laminar in nature. And if Reynolds number is greater than 4000, the flow should be a turbulent inside the pipe. Flow should be a turbulent inside the pipe. And what about the Reynolds number? Is greater than 2000 and less than 4000. So in between this range, the flow should be a transitional flow. You can say transitional type of flow, transition flow. It means our laminar flow is converting into the turbulent flow. Clear? Just going, you can say, just understand that due to laminar instability inside the flow, the laminar profile is converting into the turbulent flow. And I have already discussed about the laminar instability. And laminar instability basically depend on 4 basic factor, you can say. Clear? 4 basic factor. And what is the 4 basic factor? First factor should be the pressure intensity. Clear? The magnitude of pressure intensity. Second should be the magnitude of turbulence intensity. Clear? How much amount turbulence should be started. Clear? And third parameter should be the roughness of the pipe. Clear? The height of roughness of the pipe. And fourth one is the geometry of the curvature. Clear? And that is true for the external flow. If fluid is moving on a flat horizontal plate, or maybe you can say fluid is flowing over a sphere, or maybe that is a flow on a streamline shape body. Clear? Or you can say moving on a bluff body. So in case of these type of bodies, the shape of the body should be a matter. So these are 4 basic factors which decide the flow is being converted into, you can say these 4 basic factors should be responsible for the conversion of laminar profile into the turbulent profile. Clear? So in between the flow is called the transitional type of flow. Clear? In between the flow should be called a transitional type of flow. Okay. So the correct answer for this is the flow of fluid is viscous. No, this is not correct for this question. Clear? B is saying that in B they are saying that the Reynolds number is less than the 2000. Okay. So this is the correct answer for this. Clear? And in C they are saying that the velocity is more than the critical value. No. The fluid is ideal. No. Clear? So this is a MCQ type of question, and the correct answer should be the B. The correct answer should be the B. The Reynolds number is less than the 2000. Okay. So I hope you get the detailed and correct solution for this question. Okay. So if you have any doubt, or you can say any type of issue, you raise your comment, your inquiry in comment box. Okay, so let me move on our next question. And second question is also from a laminar flow through the pipe. Second question is also from the laminar flow through the pipe. Okay, one second question. And the second question is M type of question. Second question is MCQ type of question. And this question is for a two. This question for two. Let me first read the question carefully. In the question, they are saying that the diameter of a pipe changes from 0.2 meter at section 5 meter above the datum line. Okay, so here they are giving you the diameter of the pipe at any section, and the elevation of that section is a 5 meter. Clear? From the datum line to 0.05 meter at the section 3 meter above the datum line. Okay, the pressure of water at first section is this one in kilonewton per meter square, or you can say kPa. If the velocity of the flow at section 1 is 1 meter per second, then the pressure intensity at the section 2 is here. So basically they are saying that this section is the section 1. Let me, this section should be the 1, and this section should be the section 2. Clear? So first we are going to draw the diagram. The diameter of the pipe changes from 0.2 at a section of 5 meter above. So this diagram is like this. Okay, so this is converging type of pipe, and let me fix the datum line. So this is our datum line. You can say that this one is our datum line. Yeah, and at datum line we should assume that z is a 0. Okay, at datum line we should assume that the value of z is 0, and the fluid is moving. Let me just we should need to check the energy level. So I'm not going to draw the direction here. I'm just to the axis of the pipe. So this one is the axis of the pipe, axis of a pipe, and from axis of the pipe we should consider our elevation. So let me take this section as 1, and this section should be the 2, and the value of this elevation, let me assume that this is Z1, and this Z1 is a 5 meter, and somewhere here you can say 2, and this height, let me assume that this is our Z2, and that Z2 is the 3 meter, and this is a 5 meter. Clear? And diameter is given as, at this point diameter is given as 0.2 meter, and at section 2 the diameter should be D2, and that is 0.05 meter. And what about the pressure? At section 1 the pressure is given as P1. P1 is a 490.5 kPa. Clear? And section 2 the pressure should be the P2, and that pressure you need to determine. Okay, and the velocity is given as, at section 1, that is the V1. This should be a 1 meter per second. Clear? And we need to calculate the velocity V2 at this section. Yeah, we should need to calculate the velocity at section. So this is the simplified schematic diagram here according to the question. Okay, so first we should calculate the velocity at point 2. Let me calculate the velocity at point 2. So we have a velocity at section 1. We have velocity at section 1. So we are just going to apply our continuity equation. So let me apply the continuity. Let me apply the continuity equation. And according to this, we can say this is A1 V1 is equal to A2 V2. Clear? And A1 is what? That is pi by 4 D1 square, and that is V1. And this should be the pi by 4, and that is a D2 square into a V2. So pi by 4 get cancelled out. That is D1 square V1 is equal to a D2 square into a V2. And what about the D1 and D2? D1 is given as 0.2 and a square, and V1 is 1. And what about the D2? D2 is 0.05, so that is 0.05 square multiplied by a V2. So this should be a 0.2 square and by 0.05 square here. So the value of V2 should be a 16 meter per second. The value of V2 is 16 meter per second. Here, the velocity at section 2 should be a 16 meter per second, 16 a meter per a second. Okay. So this question they does not mention about the losses. So we should consider the energy at point 1 is equivalent to energy head at point 2. Okay. So what the energy head at point 1? E1, we should write E1 is equal to E2. What about the energy head? That is P1 divided by rho z, and plus का V1 square divided by a 2z, and plus that is Z1 is equal to, this should be a P2 divided by rho z, and plus का a V2 square divided by a 2z, and plus you can write this is the Z. You can write this is a Z2. So what about the P1? P1 is given as 490.5 kPa. 490.5 kPa, or you can write 10 to the power 3. And what about the fluid? Fluid is given as a water. Okay, so the density of the water should be 1000. This is going to be cancel out, and 9.81. Clear. And plus ka V1, it means 1 ka square divided by 2 into 9.81, and Z1 should be a 5. P2 you need to determine, rho into Z, and plus V2 is 16 square divided by 2 into 9.81, and plus datum line for section 2 is I think 3 meter. 2 is a 3 meter. Okay. So for section 2 is datum is a 3 meter. Yeah. So let me just calculate. So that is 490.5 divided by 9.81. So this will be you can say 50, and plus 1 divided by 2 into 9.81. So that is 0.0509, and plus you can say 5 is equal to P2 divided by rho z, and plus what about this 16 square divided by 2 into 9.81. So that is 13.0479 and plus 3. Clear? So what about this? 50 plus 0.00, sorry, not 10, 509 plus 5 and minus 13.0479 and plus 3. So this multiplied by 9.81. So at point 2, the pressure should be the 382.619. Here, this is the pressure intensity at section 2. This one is the pressure intensity at section 2. This is the pressure intensity at section 2, 382 something. So correct answer should be the B. B is the correct answer. B is the correct answer. P2 should be 382.619 kPa. Clear? Please tell me in a comment box whether you get this answer or not. Please tell me in comment box to understand whatever I have discussed. Please tell me in comment box. Are you able to understand this solution? Or you have some problem? Please tell me in comment box. So, okay. So I think all the people the correct answer. So let me move on next question. So move on next question. And next question is the hydrostatic pressure force. Clear? Next question is the hydrostatic pressure force on a curved surfaces. Hydrostatic pressure force on the curved surfaces. Clear? And this is one of you can say one of the easiest question from curved surface. And this question have 1 mark. This question is one of the easiest question that I can frame from hydrostatic forces. So please try the question and tell me answer in comment box. Please first to read the question and try to solve to this question. And please take all the questions seriously, because if you practice in a proper way, then you can understand the concept and so please first try to the question and try to solve the question, give the answer in comment box, and then I will discuss the question. Please try. Please try to solve the question. In this question, they have only asked here. In this question, they have only asked the horizontal force. Yeah. They have only asked about the horizontal force. You just need to calculate only horizontal force. Does not require to calculate the vertical force or resultant of force. Just need to calculate the horizontal force which is acting due to the fluid medium on the cylinder surface. Yeah. So for horizontal forces, should project the curved surface on a vertical plane. So let me just note this point is A, and this one is the B, this point is C, and this one is the D. Clear? So fluid is on this surface, left surface, and in right side you can assume that there is a air or some other gas. Clear? So the force due to air or gas medium you neglect and project to this on vertical plane. So this point may come out to be point A dash. Let me consider, and this point is B dash, and this point should be the C dash. Yeah, and this is a cylinder. So we take depth of the cylinder is, or you can say width of the cylinder. Clear? And width is I think given as 1 unit, or you can say length is given as 1 meter. Okay, so this is the projection of this on a vertical plane. This is a simple projection of this cylinder on the vertical plane. Okay, so the h bar of this plane is, this length will be, diameter is given as 2, so this is the 2 meter. So h bar should be at half of the distance, so you can say h bar is 2 meter. And what about the area of this projected plane? So area of projected plane, this is a simple rectangle. Projected plane is a 2 multiplied by 1, that is a 2 meter square. Clear? And we know that the force should be a horizontal force should be, clear, and that horizontal force is acting on the HCP. Clear? So somewhere at this point, yeah, and at a distance of HCP. A distance of HCP, this point will be a CP. Below to the centroid point. Point. So what is the magnitude of Fh? And that horizontal force is asked in kilonewton. So the force would be the rho of the water G H bar multiplied by projected area. Clear? And divided by 1000. So this is converted into the kilo Newton. Clear? Then F of H is what? That F of H is rho of the water, or you can say just we should cancel out this. So J is what? That is 9.8 multiplied by h bar is a 1 and multiplied by area. So projected area is a 2 and divided by consider this. So this is in kilonewton. So what about the force? 9.8 multiplied by 2. So that force will be the 19.6 a kilo a newton. 19.6 a kilonewton. This force is a 19.6 a kilonewton. Clear? 19.6 a kilonewton. So this force is what? That is a 19.6. Clear? 19.6 a newton. This is the horizontal force which is acting on this cylinder. Okay. So I think you should understand the solution of this question. So we should move on. Next question. And the next question is the properties of fluid. Next question is from properties of fluid from chapter 1. Clear? Properties of fluid, chapter 1 in fluid mechanics. So the question is NAT type of question. This question is NAT type of question. This question may ask, or this type of question may be asked up to 2 marks. Okay. So first we should need to read the question carefully. So in the question they are saying that a block weighing 1 kilonewton. Okay. The weight of the block is given as 1 kilonewton and having a dimension. So this dimension is given as 200 mm into 200 mm. And the base is allowed to slide down on a film of oil. Okay. So the block is moving on a film of oil. This is oil film. You can say this one is thin oil film, basically. Thin oil of film. Okay. And thickness is given as 0.05 mm as shown in the diagram. Assuming the linear velocity profile, they have already mentioned that the linear velocity profile, you need to calculate the terminal velocity of the block. Terminal velocity of the block in which unit? In the meter per second. And dynamic viscosity is given as 7 into 10 raised to the power minus 3. Clear? In this question, they have asked to calculate the terminal velocity of the block. Okay. And they have already mentioned that the velocity profile should be a linear. Velocity profile should be a linear. Okay. So let me just calculate to this question. Okay. So what they are given? They have given that this is an inclined plane and theta is 30 degree. Theta is given as I think 30 degree. And one block is placed on this inclined surface, but between the block and inclined surface there is a thin film. So the weight of this block is 1 kilonewton. The weight of the block is 1 kilonewton. And at this there is a thin film of oil. This is a thin film of oil. This thin film of oil. Thin film of oil. Thin film of oil. And in this oil medium, they have already mentioned that velocity profile is a linear. Velocity profile is a linear. Velocity profile is a linear. And let me assume that a fluid is a Newtonian. Let me assume that fluid is a Newtonian. Fluid is Newtonian. Let me assume that fluid is Newtonian. Okay. Good. Ramesh is saying that the answer is 178.5. Okay. So let me just calculate to this. And the velocity profile is linear. So what will happen? At this point, clear, we should assume that our y is equal to 0 meter, and at this point the y is h, because this gap is given as h. Okay, and we should follow the no slip velocity boundary condition. So if we follow the no slip velocity boundary condition, at this point the velocity will be a 0. Attached fluid layer have a velocity 0, and if block is moving with terminal velocity v in downward direction, so at this point the fluid layer have a velocity of v, and in between the velocity profile is linear, some like say like this. Okay, and you can easily calculate calculate the slope of this line, and that is du by d of y. Slope of this line is du by d of y, that is v minus 0 divided by h minus a 0. So this is v divided by h, and this one is the du by d of. So this one is du by d of y. Du by d of y is a v by h. Du by d of y is by h. V by h. Okay, v by h. So what will happen if you draw the free body diagram for this? So the block is try to slide in downward direction, and this angle is a 30 degree. Block it try to slide in downward direction, that force will be sine 30 degree. It's sine 30 degree. So fluid should offer a resisting shear opposite to the flow, and that is tau. We multiplied by this by a surface area to get a resisting force on the bottom of the block opposite to the motion. Clear? And this block is moving with the terminal velocity v, and acceleration of the block is so we just need to balance the forces. So you can say in inclined direction w sine theta, or you can say w sine 30 is in downward direction, and in opposite direction that is tau multiplied by surface area. Acceleration should 0, so we can just write w sine 30 is equal to tau multiplied by as. Okay, then what about the w is given as 1 kilonewton, so you just write 1000 to sine 30 it by 2, and that is mu, and velocity divided by h and multiplied by surface area. Okay, so this will become the 500, and mu is given in the question. What is the mu? Mu is 7 into 10 raised to the power minus 3, so that is 7 into 10 raised to the power minus 3, and terminal velocity we need to determine. And what about the h? H is given as 0.05 mm. 0.05 mm. So you just write 0.05 mm, it means 10 raised to the power minus 3. And dimension is given as 200 mm, 200 mm. We just write multiplied by 0.2 and 0.2. Clear? So let's calculate. That will come out to be 500 multiplied by 0.05 into 10 raised to the power minus 3 and divided by 7 into 10 raised to the power minus 3 divided by 0.04. So I think that will come out, yeah, the terminal velocity will come out to be 89.285 clear meter per second, I think. Clear? Or you can write that is 89.29 meter per second up to 2 decimal places. Clear? Up to 2 decimal places. Up to 2 decimal places you can write 88.29 meter per second. I think this is the correct answer. Yeah, Tejas. Clear? I think this one is the correct answer. 88.29 meter per second. This should be the correct answer. Please remember that when they ask about the terminal velocity will come when the acceleration should be 0. Yeah. body moving with a constant velocity or without any acceleration. So this is the correct answer, 88.2 meter per second. Okay, and I hope you can understand the solution of this question. So answer should be 88.9. 88.2. So let me move on. Next question. And next question is fluid as a rigid body a motion. Next question is from fluid as a rigid body a motion. Next question is from why gate Wallah not mention the teacher name? I have already okay. I think you talking about the link which is created by the technical person. Sir 89 आएगा. एक second. Just give me 1 minute. Sir 89 आएगा. 89 आ रहा है क्या? इसका आंसर 89 आ रहा है क्या? Sin 30 आएगा ना? 89 नहीं आएगा. Just give me 1 minute. 9 नहीं आएगा. 1 किलो न्यूटन है. 7 न्यूटन. ठीक है. Okay. So let me just calculate cross check the answer. 0.05 into 10 raised to the power minus 3 and divided by 7 into 10 raised to the power minus 3 divided by 0.04. Okay, I have taken a mistake. Okay, that is 89. So that is 89. Yes, at top it is written 89 and bottom I have get. So that is 89. 89. This is 89, not 88. That is 89. Okay. Okay. That is 89. That is 89, not 88. Sorry for that. Okay. So let me move on next question. And that question is MSQ type of question. Clear? MSQ type of question. And the label of the question is up to 2 marks. Clear? So read the question carefully because maybe more than one answer is correct. Clear? हाँ, FM का महा रिवीजन जो है 1 फरवरी is on 1 February. Is scheduled on 1 February. Fluid mechanics Maha revision is on 1 February. 1 February. Maha revision session is scheduled on 1 February. 1 February. I should start from the starting. Clear? From chapter 1, properties of fluid. Okay. So first we should need the question. A rectangular tank 3 meter long, 2 meter wide and 2.5 meter depth contains water to a depth of 1.5 a meter. It is accelerated horizontally at 3 meter per second square in the direction of its length. Okay. So let me first draw the diagram. What they are saying. Clear? Let me draw the diagram. So in this question they are saying that there is a trolley or you can say a tank which is moving on a horizontal track. So let me take this as a trolley. This is a trolley which is moving on a horizontal track. Clear? And I have assumed that this direction is the x. Let me take this direction is x and vertical you can say z direction. Let me take this as a y direction. So this tank is moving in x direction with the acceleration. Acceleration is 3 meter per second. The acceleration should be 3 meter per second. Okay, thank you, those. Thank you. Okay, thank you. So let me take horizontally at 3 meter per second square in the direction of the length a rectangular tank 3 meter long. So it means this is given as, let me take, this is the 2A and 2A is 3 meter is given. Okay, so you can say A should be 1.5 a meter. Clear? That is 1.5 meter, and width is given as a 2 meter. So the width of the tank is given as a 2 a meter. And what about the height? Height of the tank is given as 2.5 a meter, or you can say depth of the tank. So the height is given as, this height is given as 2.5 a meter. Clear? This is given as a 2.5 a meter. And initially the water is filled up to the height of 1.5 a meter. Clear? So initially, let me take, this is the initial depth of the water, and we have assumed that this is H0. So this one is 1.5. This height should be a 1.5 a meter. H0 is 1.5 meter. Okay, Prakash, I think A is correct. Clear? Okay, good. So this is H0 and H0 is 1.5 a meter. Then what will happen? Then which one or more of the following statement is going to be correct? Clear? Slope of the free surface, total force on a bottom side. Clear? Spill out the value. So see, in this type of problem, first you need to check whether fluid is spill out or not. Clear? So what is the condition for the spill out? What is the condition for the spill out? Condition of spill out. What is the condition for spill out? Condition of the spill out is, first one, if H0 plus delta H. Okay? Delta H is the rise of the fluid. Here, rise, or you can say depression of the fluid. Rise of fluid due to acceleration. Rise of fluid due to acceleration. Due to acceleration. Clear? What will happen? When the trolley is moving in horizontal direction, in positive x direction, then the molecule, fluid molecule should feel a pseudo type of force in opposite of the motion. Clear? So they are, you can say, collected in back side of the trolley, and you can just understand that on the back side of the trolley, fluid start rising due to, you can say, pseudo force. If we consider the trolley as our frame of reference, and front side fall of the fluid. Okay, so fall of the fluid. So this is a rise of fluid due to acceleration, and if this is a greater than, you can say, the total height of the tank, then no fluid is spill out the tank. Spill out from the tank. Spill out from the tank. And what will happen? Second thing is the if H0 plus, and this equal to, you can also consider, and if this delta H is less than capital H, then what will happen? Then fluid should spill out. Then fluid should spill out from the tank. Then fluid should spill out from the tank. Okay. Then, so we know that the tan theta should be the slope of this. Let me take this as dz by dx. Clear? So that slope should be ax by g. and that you also write A delta H by A. Delta H by A. Okay. So let me first calculate the slope of this. Clear. And this slope, you can just say that theta is, if we assume that, let me first assume this is the free surface, final free surface. First we should assume that this is our final free surface. Okay. So let me draw the another diagram. This is our trolley. This is our trolley. And if we consider this is our mid axis, this one is our mid plane axis. This one is our mid plane axis. Initial free surface is this one. Initial free surface is this one. And final free surface, let me take this one. Final free surface is this one is our final surface. This is our final free surface. This line is a straight line. Okay. Then this angle, this axis is the z axis, and this one is x axis. This angle should be, let's take this as alpha, and I have considered this as a theta. Okay. This is a theta. So what about this? This point is the point of A, and this is a point B, and let me consider this is. So this rise in height is delta H. This rise in height is a delta H. Here, this rise in height is delta H. So this is also a delta H. So first we need to calculate this delta H. Clear? So delta H, we can calculate tan theta. Tan theta, we know that this delta H, or you can say Ax by G, Ax by G, and that is a delta H divided by, okay, delta H divided by A. And we know the value of Ax. Ax is given as 3. So this is, you can say 3 divided by 9.81. And let me take this first as tan theta. Clear. So tan theta is what? That is 3 divided by 9.81. 3 divided by 9.81. And this tan of inverse. So theta will come out the 17.004 a degree. Or you can say that is 17 a degree. Theta will come out the 17 degree. And what about the delta H? So delta H is Ax multiplied by A and divided by G. So that is multiplied by A. And what about the A? 2A is given as 3 meter. So A should be a 1.5 meter. So that is 1.5 meter and divided by 9.8 of 1. So you can say 3 multiplied by 1.5 divided by 9.81. So delta H is 0.4587 a meter. This is the value of rise of the fluid on the back surface, or you can say back face. So what is the value of H naught plus delta H? So H naught is given as 1.5, I think. 1.5 and total is 2. That is 1.5 and plus 0.4587. So 1.5. So that will become a 1.9587 a meter, and which is less than that 2.5 a meter. So from here you can say that no spill out of the okay, no spill out of the fluid. There's no any type of spill out of the. So one answer we get, that is 17. So this is correct. And the volume spill out, this is wrong. Clear, because there is no any type of spill of the fluid. So we just need to calculate the pressure on the front and back side of the container. So front and back of the container. Let me just draw. At back side, this will become a height become the this height becomes 1.9587. That is 1.9587 meter, and this height will become this height will become you can say 1.5 minus 0.4587. So this height will become 1.0413 a meter. This height will become this. Okay. So let me calculate the forces. So at this phase, the value of pressure, let me take as this is FP1, and from this side, let me consider that is FP2. So what about the FP1? FP1 is a row of water, that is 9.81, and H bar is this, half of this. So 1.9587 divided by 2, that is 0.97935, and multiplied by area. So width multiplied by height. Width is given as a 2 meter. Width is given as 2 meter. That is 2 into 1.9587, and divided by, you can say, 1000. So 1000 is get cancel out, and this is in kilonewton. So what should be the force on a front? That force will be the 9.81 multiplied by 0.7935 multiplied by 2 multiplied by 1.9587. Clear? So that will come out to the 636 kilonewton. I think this will correct. And FP2 is what? That is a rho, it means water, multiplied by 9.81 multiplied by H bar. So let me write 10413 divided by 2 and multiplied by area. Area is 2 into 1.0413 and divided by 1000. So that is becoming kilo. So this will get cancelled out. So this one is 9.81 multiplied by 1.0413 divided by 2 multiplied by 2 multiplied by 1.0413. So I think this will correct, but I make a mistake. Let me just first write. This one is in kilo. This is, I make a mistake. So total force is 10 point. Okay, that will come. So answer should be the A and B. Yeah, this is wrong. I think calculation is okay. So on the back side, Fe1 is Tejas. On the back side, the pressure forces on back face, the pressure should be the 37.63 kilonewton, and on the front face, the pressure should be 10.6. Sides are fall is this one, and angle is 17 degree. Okay, so I hope you get the correct solution. So let me move on next question. Okay, so let me on next question, and for this question, the correct answer is A and B. This question is the correct answer is A and B. So let me move on next. And the next question is from the fluid kinematics. Next question is from the fluid kinematics. Okay. Read the question carefully. Read the question carefully. This question is from fluid kinematics. Okay. Read the question carefully. What are saying the question? They are saying that a two-dimensional flow is described by velocity component. U is given as this, and y direction velocity always given as this. Then at point 1 comma 2 is at point 1 comma 2, which answer is correct? Yeah. And psi is denote the stream function. Psi is a psi denoting the stream function. So which answer is going to be correct? Read the question carefully. A. Okay, good. Tejas. Read the question carefully. And Tejas is saying that A is correct. The question. We know that Q is what? That is plus del psi by del y. Del of y. Then del psi by del of y. And U is given as 5x. So if we integrate, we get a 5 x cube y and plus one integration constant c1. Yeah, and you may say that this integration constant is the pure function of x. So let me take this as a pure function of x. I have considered this as a pure function of x. This one is our sign. This one is the pure function of x, and that is the sign. And what about the y direction velocity? Y direction velocity is given as minus del psi by del x, and this is minus 15 x square y. Okay, x square y. So del psi by del of x is what? That is 15 x square y. And if you integrate, you get the another stream function sine 2. That is stream function is 15 x square, x cube y divided by 3 plus one integration constant c. So you can write sine 2 is the 5x cube y and the pure function of y. We know that the stream function of flow field is single type of a stream function. You cannot define, you can say at any condition, two different stream functions. So let me just speak by comparison method. If you compare this, there is no any pure function of x. You just simply write fx is 0. And if we compare this from this equation, so there is no any function of pure function of y. This is also 0. So sine 1 is sine 2, and that will become a 5x cube y. 5x cube y. They are 5x cube y. And then at point 1 comma 2, at point 1 comma 2, that is 5 multiplied 1 square multiplied by 2. So that is 10 meter per second cube. That is, I think this is not centimeter cube. That will meter cube per second. I think. Okay. So the answer will be the. So for this question, first answer should be the A. Okay. For this MSQ, first answer is A. first answer should be the A. Let me check the second answer. And second, they are saying that acceleration, total and y direction acceleration. So first we are going to check the y direction acceleration, then total. So let me first check the y direction acceleration. So y direction acceleration, that will become the u, del u by del of, that is del v by del of x, and plus a small v, plus a small v, and that is del v by del of y, and plus w del v by del of z, and plus del v by del of, you know the value of u and v, that is 5x cube. U is the 5x cube, and v is the minus 15 x square y, minus 15 x square y. Okay, okay. So let me just put to this is 5x cube, and what about del v by del x? That is a minus ka 30 x y. Okay, and plus minus ka 15 x square y, and del v by del x, minus ka 15, you can say x square, plus both term comma. Good. Total acceleration you have calculated. Okay. So what about the AY? AY should come out to be that is del v by del x. Make a mistake, I think. 5x cube, that is 5x cube, that is minus ka 50 x ki power 4 y, and that become minus plus 25 x ki power 4 and y. So minus ka 150 multiplied by 1 multiplied by 2 plus 225 multiplied by 1 multiplied by 2. So I think this will become minus 300, 450. So that is 150 meter per second. Clear? So that is not correct. Not correct. This is not correct. Okay. So I think this will. So please calculate just AX and then calculate the total. So to calculate the AX, you know the value of AX is u, del u by del of x, here plus ka v, and del u by del of y, and plus w, del u by del of z, plus del v by del of here. So you just need to calculate the A of x and then A total, and this is for you homework. You can say this is the homework for you. Calculate to here. Always remember the del operator. Clear? In kinematics, always remember the del operator. That is d by dt is what? That is u. Sorry, not u. That is del by del of x. That is small v. Del by del of y plus w del by del of z, and plus del by del of t. Please remember this del operator. Please remember this del operator in fluid kinematics. This is, you can say, the del operator. This is a del operator. So please remember this del operator in fluid kinematics. Fluid kinematics. Remember to this del operator kinematics. Okay. So let me move on next. And next question is from the fluid dynamics. Next question is from the fluid dynamics. So please read the question, and the question is NAT type of question. This question So read the question carefully. What is saying in the question? Let's simply say that a large tank shown in the figure has a vertical pipe 70 centimeter, you can say long. The length is 70 centimeter and 2 centimeter in diameter. Okay, the diameter is given. The tank contains an oil of density of 920 kg per meter cube and viscosity of this poise. Then the amount of discharge to the tube when the length of the level in the tank is 0.8 meter above the this. Okay, just need to apply and say just need to apply the energy conservation. So at this point the energy head is even and at this point the energy head is 8. Here viscosity is given as 1.5 poise. Then what will happen? Then amount of discharge to the tube when the height of the oil tank in the tank is 0.8 meter above the pipe head. Okay, so assume that there is a fully developed laminar flow, and first you should need to calculate the mean velocity of the flow multiplied by the area, you get the discharge. So at this point the event, let me take this as a datum line. So at this z is 0 and this label that z should be the 170, you can say 1.5 meter. Okay, the side will be 1.5 and we are going only consider the losses in the pipe. Here only in the pipe. So at this point even and velocity is what? Let me consider that is 0. At this point velocity in pipe we should consider velocity is a. So E1 is equal to E2 plus ka HLF in the pipe. E1 is what? That is 1.5 meter. Here because a pressure is ATM. At this point pressure is 80 and the gauge or vacuum of the ATM is a 0. And at this point also the pressure is 80. So both P1 by rho c and P2 by rho c both becomes a 0. Both becomes a 0. So velocity is also 0. E1 is only 1.5 meter, that is our datum head, is equal to E2. Pressure head is 0. So let me write this. Pressure head and velocity head both are 0. So this is a V2 square divided by 2. And what about the datum? Datum is 0. And plus losses. And losses is, let's assume 32 mu velocity V2. Then 32 mu V2L divided by rho z d square diameter ka square. Clear? So answer is 0. No, not 0. Prakash, Rudra Prakash, I think you have make a mistake somewhere. Let me first calculate the velocity. That is 1.5 is equal to V2 square divided by 2 and plus 32 V2L divided by rho z a d s. Okay, so that is 1.5 and V2 we need to calculate it. Let me just the value here, or you can say going to multiply this by 2z. So here become a 60 multiplied by mu. What about the mu? What about the mu? Mu is given as dynamic viscosity given as, what is the dynamic viscosity? Dynamic viscosity is given as 1.5 poise. So that is 0.15. We need to calculate the V2. Length is given as 80 centimeter, 70 centimeter. That is 0.7 and divided by rho. Rho is 920. And 920 into diameter ka square. Diameter is 2 centimeter. So that is 2 divided by 100 to 0.0. Square up this. Square up this. Okay. So let me calculate this first. Multiplied by 9.81. 2 multiply 1.5. So that will come out to be the 29.4 is equal to V2 square plus 64 multiplied by 0.15 into 0.7 divided by 920 divided by 0.02 the square of this. So yeah, sorry, this will come out to 18.26 of V. Okay. I think calculation will. So this is the quadratic equation plus 6 of V2 minus the 29.43 is equal to 0. Let me just calculate the V2, that is minus ka 18.26 and plus minus. So I'm not going to consider the minus. Under root 18.26 ka square minus plus, that is 4 into E into 1 into 29.43 and divided by 2. A is what? Is 1. So it will become 4 into 1 into 29.43. Here. And under root of this minus 18.26 divided by 2. So I think if I am correct in calculation, so that velocity is 1.49 meter per second. Please verify the calculation because I'm very weak in calculation. Please once verify the calculation. 1.49 meter per second. Good evening, good evening. Clear. So that will come out to be the 1 point this. So diameter is 2. What about the discharge? Discharge is a V2 multiplied by area. And area of the pipe is pi by 4. So that is 1.49 multiplied by pi divided by 4 multiplied by 0.02. Clear? Abhijit, good evening. Good evening. So this multiplied by pi divided by 4 multiplied by 0.02 I square. So determine that is not meter, that is in a liter. Liter per second. This is in a liter per second. Liter per second. So multiplied by 1000. This comes out to be 0.468. Here. Or you can say that is 0.47 liter per. Okay. So I think you get the correct solution. Please just once go through the calculation. Okay. So we should move on next question, and the next question is from impact of watershed. 0.6468. Okay, good. Thank you, Prakash. Thank you, Dosh. Thank you. Thank you. So we should move on next question, and that is impact of watershed. Read the question carefully. That is NAT type of question. NAT type of question. That question 1 mark. Read the question carefully. Impact of watershed. But a small question you read the question. Okay, so let me read the question. A watershed of a diameter is given as this. Strike on a stationary smooth flat plate. Normally, but with a velocity of 20 meter per second. The force in kilonewton exerted by the water. Okay, so let me draw the diagram first. This is our smooth flat plate, and at center there is a splitter. So our smooth flat plate, the one is normal axis, a smooth flat plate. One is a smooth flat plate, and water jet is strike normally. So take this as a nozzle, and water jet is coming and get splitted into part. Water jet is splitted in water jet is splitted into different parts. Yeah. Water jet is splitted into different parts. So diameter is given, velocity is given, d is given, v1 or we can say v is given. So the force exerted by the water jet on the plate is Fx. So what about the Fx? Fx is the rho area of the jet into velocity I square. Okay. Because final momentum is the direction of jet. In x direction you can say. So density of the water is given, and you need to calculate in kilonewton. We are just going to divide the 1000. Let me cancel out. So area of the jet is pi by 4. And what about the diameter? Diameter is given as 0.075 mm meter, and velocity is 20 square. So you get the 0.075 square multiplied by pi divided by 4 and multiplied by 400. So you get the 1.767 kilonewton, or you can say 1.77. So this is our f of x. This is our f of x, and that f of x is 1.77 kilonewton. Okay, so let me move on next. The next concept is concept of manometry. Next topic is concept of manometry, pressure measurement. Okay, so again, any type of question, read the question carefully. Read the question carefully, what they are saying. Okay, so let me read the question first. In question, they are saying that a U-tube opened at both end and made 8 mm diameter class. Okay, good. So there is a U-tube manometer which is open on both the end. This tube is open at both end. Okay. And diameter has mercury in the bottom of a height of 10 centimeters. Initially, the fluid is a mercury at the bottom. So initially, there is a mercury. You can say this mercury. The height of this is at that is 10 centimeter. The height should be a 10 centimeter. Yeah. Initially, in the tube, in the bottom, there is a mercury having a height of 10 centimeter. Having the height is 10 centimeter. Clear? A bore height of 10 centimeter, a bore the horizontal limb. If the 20 cc is 20 centimeter cube of water is added to one of the limb, let's say in this limb, water is added. In this limb, if water is added, clear, and what amount of water is added? That is 20 c. Clear? It means 20 into 10 raised the power minus 6 meter cube. Water is added to one of the limb. The difference in mercury level at equilibrium is given by. Then what is happen? What will happen? This surface will get down and this is rise upward. So what will happen? Then you can say there will be a rise and fall. This rise and fall. Let me take this as rise and fall. Okay, the diameter is given as D, and that diameter is what? That is 8 mm. What is the area of the tube? And where is the water? Water is somewhere, you can say. So this is the water which you have added, and initial level is somewhere this mercury initial level. So in left arm, if y distance mercury have depressed, so in right limb the distance is the, so total deflection in mercury is a 2y. This total deflection in mercury should be a 2y. Total deflection in mercury should be a 2y. So what will happen? Area is, that is a pi by 4, 0.08, 8 divided by 1000, 8 divided by 1000, that is one more square. The square of this multiplied by, you can say, pi, and multiplied, sorry, not multiplied by 4. So area should be the 5.0265 into 10 raised to the power minus 5. And what is the volume? So you can say 20 into 10 raised to the power minus 6 and divide by answer. So the height of water which you have added, clear, that height should be h is equal to 39.79 centimeter. Yeah, that you have added. So what will happen? We just need to move from this point to this. Clear, and we can direct balance. So the height of the water which you have added multiplied by rho of the water multiplied by z is equal to twice of the y multiplied by rho of the mercury. So this g get cancel out, and that should be a 39.79 into rho of the water, that is 1000, is a 2 multiplied by y multiplied by 13600. Clear? So that 30 is get cancel out, and then what will happen? So 39.79 and divided by 2 into 13.6. Clear? 13.6. 13.6. So your y is comes out to be 1.46286 centimeter. Okay? Okay. The difference in the mercury level at the equilibrium is, okay, so you need to calculate the twice of the difference. It means you need to calculate the 2i. Okay, the difference between left and right arm you need to calculate. So that is 2.925 centimeter. Yeah. The answer should be the 2.93 a cent. The answer should be the 2.93 centimeter. 2.93 centimeter. Good. Okay. 2.93 centimeter. And this type of question is asked in GATE. Clear? I think 2 to 3 times this type of question is asked. Please practice these type of questions. Okay? So let me move on next question. I hope you can understand the. So let me move on next question. So next question is from boundary layer theory, and that is M's type of question. And one of previous question, which can you make from boundary layer theory? That is 1 mark. What they are saying, In a laminar boundary layer over a flat plate, the ratio of shear are tau 1 and tau 2. A two section is okay. So we know that if this is our boundary layer, this one is our leading edge, x is equal to 0 meter. So this should be a leading edge. This one is our leading. Okay. I have considered this is x axis or y axis. Let me this is. So at any distance, you can say x1. The wall shear is tau 1 and some other distance x2. That wall shear is a tau 2. Okay? And from boundary layer concept, we know that tau is inversely proportional to x. Tau 1 is inversely proportional to under root x1 and tau 2 inversely proportional under root 1 by. And tau 1 by tau 2 is what? That is under root x2 by x. Then what they are saying, tau 1 and tau 2 section 1 and 2 at a distance from the leading edge such that x2 is equal to 4 times x1. So simply you can say that tau is that is 4 times I think 1. So that is 4 times x1 divided by x. That is clear. So the ratio will be B will be the correct answer. B will be the correct answer. Ratio should be the x2 is the 4 times of x1. So the correct answer should be the okay. So I hope you get the correct circuit. So let me move on. Another question. And the next question is from the concept of the buoyancy. And please, for gate point of view, buoyancy and meta center is also you can say important topic. Practice buoyancy and meta center. Read the question carefully. What they are saying. After this, MSQ, there is one more question from turbulent. One question from turbulent. So I have tried to cover each and every topic. Okay, so what are saying in this question, and that question is up to 2. What they are saying that a solid cylinder of diameter 30 centimeter and the height is 15 centimeter float with its axis vertical in the sea. Water relative density is 1.03, and if the relative density of the cylinder is 0.9, then which statement should be correct? Okay, and that is Gm. That is G of metacentric height, G of M. You need to determine the Gm, and once you get the value of Gm, you should predict the state of equilibrium. Clear? Because we know that Gm is a positive, then body is in stable equilibrium under floating condition, and if our metacentric height is negative, body is unstable equilibrium, and if metacenter is coincide to the center of gravity, then body is in neutral during the float. So let me first draw the diagram. 30 centimeter diameter. So the cylinder, and you can say the cylinder is floating inside a water medium. So a diameter is given as, the diameter D is given as 30 centimeter. Diameter is given as 30 centimeter and total height is given as 15 centimeter. So the length is given as a 15 centimeter. 15 centimeter. And I have assumed that the depth of submergence is Y. I have assumed that the depth of submergence is. So first we need to calculate the Y. Thus we going to balance the buoyancy to weight of the body. So area multiplied by Y multiplied by rho of the water multiplied by G. This is the buoyancy force. This one is the buoyancy force. This one is buoyancy. And what about the weight of the body? relative density of the body is given as 0.9, and you can say, let me division of the body multiplied by length multiplied by area multiplied by g. Okay, what get this will get cancelled out. So y multiplied by 1.03 relative density, and that is 0.9 multiplied by L. So what is the value of y? 0.9 multiplied by, you can say 15, and divided by 1.03. So that will come out to the 13.106, or you can say 13.11 centimeter. So this will come out the 13.11 centimeter. This will come out to be the 13.11 centimeter. 13.11 centimeter. Okay. Then what will happen? So we need to calculate the BM and BG. We know that the GM will what? That is BM minus B. What about the BM? What about the BM? BM is the I divided by displaced volume. I will what? That is pi by 4, pi by 64, d ki power 4, and divided by pi d square by 4, displaced volume, it means y. So calculate for this pi square. So that will become the d square divided by 16 y. What about the d? D is given as 30 centimeter. So that 30 square divided by 16 multiplied by 13.11. So this multiplied by 16 and 900 divided by answer. So that is a 4.29167 centimeter. This is our BM. BM is also called the metacentric radius. This will also called the metacentric radius. Metacentric radius. And GM will call the metacentric height. The metacentric height. This is our metacentric height and this is metacentric radius. So, and what about the BZ? Let me just write CM is equal to BM, the 4.29167 minus B is L by 2 minus ka Y by 2. So this will become 4.29167 minus L. L is the 15 divided by 2 minus ka 13.11 divided by 2. So this minus 7.5, 13.11 divided by 2. So that will come out the 3.346 or 7 centimeter. This could be our GM. Our GM. This should be our GM. 3.3467 centimeter. So, and GM is positive. And GM is greater than 0. Or you can say positive. So, we can say the body is in stable equilibrium. Body is in stable equilibrium. Clear? So, this is, you can say positive. This. And body is in stable equilibrium. Body is in stable equilibrium. So for this question, A and C will be correct. For this question, A and C will be the correct. A and C will be the correct. Okay. So let me move on next. Next question is the turbulent flow. Okay. And that is the MSQ type of question. Yeah. So I have I have always said that in a turbulent flow, Prandtl mixing length is very important. So let me just read the question. Prandtl mixing length in a pipe flow is what? That is L is equal to K into Y, where K is the Karman constant. K is a Karman constant. K is Karman a constant. Okay, so that is 0.8, 0.4. Because Karman constant for our course is 0.4. And what will happen? And y distance from the circumference. A constant value? No. Maximum at the center of the pipe? Yes. Because at center of the pipe, that will become R. And 0 at the wall? Yes. At this is at center of the pipe. And at surface, this will become 0. Because at surface, y is equal to. So at center, the Prandtl mixing length is maximum, and at you can say surface, the Prandtl mixing length is a minimum. Maximum at wall surface. The correct answer is B and C. So correct answer is the B and C, and I hope you get the correct. Okay, so thank you all of you, and I hope you should enjoy the session and learn some new concept, or you can say just revising whatever you have studied till now. So be focused and give your 100% for GATE 2023. Okay, and best of luck for your examination. Thank you.